Okay. In the last video lecture, we talked about the replacement method and how you can use that to assess whether there is uh, a sentence that is a first order validity, right? So that's the level between being a tautology or being a logical truth, right? We had this in-between layer where what we're doing is paying attention to not just the connectives, but we're paying attention to the quantifiers and identity, but we're not paying attention to information about other predicates like left of or smaller than. So in this exercise in 10.9, you're going to be asked to apply potentially that method or the ability to recognize those three different levels of information. So, right, going over the instructions, it says to paraphrase each sentence in Carnap sentences. I'm going to show you that in a moment in colloquial English and make sure that you understand whether it is true or not in the particular world, in this case, Bolzano's world. Then for number two, right, what you're going to do is decide whether that sentence is a logical truth. If it's not, right, so if sentence is not a logical truth, then we should be able to build a counterexample. And so you then are tasked to build a world where the sentence comes out false. And you'll name that world then 10.9 point, whatever the particular sentence number is, and they give you a hint. There should be three of these sentences that are not logical truths. The third component, right, is asking which of those sentences are first order validities. So first order validity, right, is almost a logical truth, but you don't need information about the particular predicates, but you do need information about the quantifiers and potentially identity. So there are three there are three first order validities in Carnap sentences. And then there's four sentences where you're going to apply the replacement method to come up with what are called first order counterexamples. Okay, so let me look at, let's look at 10.9 together and just go over a handful of these examples. So I'm going to share Tarski's world. There we go. Okay, so I've just made the Bolzano's world. I'm looking at it from the top down so that I can just better see the position of everything. And then I've got my Carnap sentences over here on the right. And sorry, I just want to be able to make sure if I want to that I have the option to annotate. So just give me a second here. Okay. So when looking at Carnap sentences, let's have a quick look at the first sentence. So here we're saying, right, we've got a universal quantifier, and this is saying if all the objects that satisfy the condition of being left of B, right, all those objects that satisfy that condition will then also satisfy the second condition, namely being where B is to the right of them. So if we look right at this world, we should recognize that that's true. And in fact, on second reflection, we might recognize that, oh, wait a minute, we know that left of and right of are inverses of one another. So anytime where one object is left of some other one, we know that other one is going to be right of that first object, right? So if A is left of B, then we know B is right of A. So now we should ask ourselves, that reasoning that we just did it matter that we're using the quantifier, right? If we had replaced, for example, the universal quantifier with an existential quantifier right here, would we get a different result? And the answer would be yes, right? It matters that we're using the universal quantifier here, right? We're saying not just that in some cases, but in all cases, this rule holds. And the next question we then should ask is, how much did the actual predicates matter? Does it matter that we used right of and left of, right? Did that contribute to our reasoning, right, that one is always true? And the answer again here is yes, right? Because if I had replaced right of and left of with some nonsense predicates, then that wouldn't necessarily hold, right? If I had for all x, if x is brillig to b, then b is squadlydad to x. If you don't know what squadlydad or brillig mean, then that sentence could come out true or it could come out false. So number one is actually going to be a logical truth for that reason, right? Because we're making use of the connective. In this case, we're making use of the conditional. We're also making use of the universal quantifier when we're reasoning about this. And we're also making use of the particular meanings of left of and right of in order to be able to make that assessment. Okay, so let me look ahead now at another one. Let's look at number 4. So number 4, right, if we use again the truth functional method, we'll see that you have a sentence here, dodec D, then we've got the conditional, and then we've got this universal quantifier where the range or the scope of that universal quantifier goes all the way out to that end. So the truth functional form of that sentence is something like this. If A, then B. And that would not be a tautology. So it's not a tautology. We know it's at least true in this world. If you just click on the button right, and you'll get the assessment for that. But now we want to ask, okay, so is it a logical truth at all? Or is it a first order validity? So let's look back and let's help ourselves with all the information. We're saying if D satisfies being a dodec, which it happens to in this world, then the following holds. For all x, for all things that are identical to D, then x is also a dodec. Well, what this is saying is that any object in the domain that satisfies this first condition, right, where this first antecedent condition is being identical to D. So say you've got another object named, or you have an object named B, and it also satisfies the condition of being identical to D. So in this case, that would not be possible given Bolzano's world. But so let me use a different name. Let's say we have H, right? So if we have an object called H and H names the same thing as D, does H then also have the property of being a dodec? And the answer is, yeah, it would also have that property, right? Any two, right? Because there aren't really two, but any object that has two names, right? What's true of the one name is going to also be true of the object that's referred to by the second name. So it is a logical truth. Well, we should ask if it's even more restricted, right? In that, how much did it matter that what we called that D is actually a dodec? In other words, how much does it matter that, or how much does this predicate actually matter? So let's try the replacement method. Let's try 4, and let's replace dodec with, wow, couldn't come up with something on the top of my head that quickly. Let's call it a dibble. Let's replace dodec with dibble. Okay, so now this would say if D is a dibble, then for all things identical to D, they are dibble. We have no idea what dibble is, right? That's a nonsense predicate, but we know that is still, that number 4 is still true, right? Because any object or anything else that names the same object as what D names, it also has to have all the same properties as what D has. So if D has the property of being a dibble, then all the other things that are identical to D also have that property of being a dibble. So it didn't actually matter that D is a particular dodec, right? It did, however, matter for us to analyze for that we've got the universal quantifier and that we're using the identity. And if you remember from the last video, as long as you're only using information about the connectives, the quantifiers, and identity, if that's all the information that you're using and it doesn't matter about the particular meanings of the other predicates, then that sentence would come out as a first order validity. So for is a first order validity. Okay, so that gives you a feel for how to work through these particular sentences and using a combination of the truth functional form algorithm and the replacement method to try to assess whether the sentences are tautologies, first order validities, logical truths, or none of them.